So what happens when there's no easy variable to work with? Well, things get a little rough, but we can work it out still. So the first thing we want to do is to label our equations, equation 1 and equation 2. And I'm going to pick an equation to work with. I'm going to work with equation 1. And I'm going to say, rewrite equation 1. Good. So I'm going to rewrite equation 1 to get 4x plus 3y is equal to 17. And at this point, I'm going to try to solve for a variable. I'm going to try to make x the subject. So if I'm going to do that, that means I need to take this positive 3y and carry it across the equal sign. When I do that, it's going to become minus 3y. So 4x is going to be equal to 17 minus 3y. But I want x by itself. So that means I need to divide both sides and all of it by 4. Wow. So 4 into 4, that cancels, leaving me with just x. So x is equal to this scary looking thing. It's called an algebraic fraction. But guess what? We're not afraid of stuff. We'll sort it out. Good. So this is what x is. Now I'm going to say, since x is equal to all of this, I'm going to substitute it into the equation that I didn't use. And remember, we rewrote equation 1, so we'd never touch equation 2 at all. So I'm going to substitute it into equation 2. So I have to rewrite equation 2 first, which was that 5x minus 2y is equal to 4. And remember, wherever we see x, we're going to take out x and put in this algebraic fraction. And when we're substituting, we're going to use brackets. So here's that x, and I'm going to use brackets to put in 17 minus 3y all over 4. And notice that 5 came before that x, so this 5 going to come back. And I'm going to put back everything that was around that x. Now this is where it gets a little tricky. Oh. So we're going to have to take this 5 now and distribute it inside the bracket. So it's going to be 5 times that 17. And that will give us 85. And we're going to use the distributive property same way. 5 times this minus 3y. And that will give us minus 15y. Remember, it was all over 4, so you have to put it back all over 4. And then keep everything that you had before. So you see we'll work it down little. Just take your time, man. So what we're going to do is to work with this algebraic fraction. I'm going to convert this whole by putting it over 1, and that's how I turn it into a fraction. Now watch me. Using the butterfly method, I'm going to solve this, which means I'm going to cross multiply. So I'm multiplying this one with whatever is at the top up here, and then I'm going to multiply this 4 with this minus 2y. So we're going to see 1 times 85, that will give us 85. And 1 times negative 15y will give us negative 15y. Good. So that takes care of that part. We need to do 4 times negative 2y. That will give us minus 8y. And interestingly, we must also multiply the denominators. That's going to give us our new denominator. So 4 times 1 will give us 4. And that should be equal to 4 on the right. Not bad so far, right? So we're going to have to solve for the variable y. We could first group the like terms. Let's try that. So we have that minus 15 and minus 8. So minus 15 minus 8. That gives us negative 23. And because it has y, we're going to put a y on that. So we're going to have minus 23y and that 85 all over 4. See how things are getting a little simpler now? So we need to solve for y. First thing we have to do is to get rid of this divide by 4. So we're going to have to multiply both sides by 4 to get rid of that denominator. So look what that does. This multiply by 4 cancels this divide by 4. So we're going to have 85 minus 23y. And that's going to be equal to 4 times 4. Remember, brackets like this mean to multiply. So 4 times 4 is 16. Great. So I need a little more space. So I'm going to come over this side. I'm going to go... So we're going to have 85. And we're subtracting 23y from that. And that should give us 16. So we're going to solve for y now. So I'm going to have to move this 85 across the equal sign. And remember, when I switch the side, I also switch the sign. So it was a positive 85. When I carry it across, it's going to become a negative 85. There was a 16 and this minus 23y. Good. So things are getting a little simpler now. So we're going to put that in the calculator. 16 minus 85, and that's negative 69. So we're going to have negative 69 here. And we're going to bring down this negative 23y. So to get y on its own now, I need to divide both sides, not by 23, but by negative 23. So these will cancel, leaving me with just y. And I'm going to put this in my calculator. Negative 69 divided by negative 23. And that gives us a positive 3. So y is equal to 3. Woo! We're almost there. So we know that y has a value of 3. We just need a value for x now. So we're going to come and see, since y is equal to 3, we're going to want to substitute y equals 3 into any equation. And I'm going to pick equation 2 because it looks simple. Right? And we've done a lot of work already. So I'm going to rewrite equation 2, which is 5x minus 2y is equal to 4. And wherever we see y, we're going to put that 3. So this is where the y is. I'm going to replace it with 3, and I'm putting it in brackets. Notice there was that negative 2 in front and this 5x in front, and that minus 4 behind. We're just going to work it out simple. Negative 2 times 3 will give us negative 6. We'll have this 5x equal 4. And we're going to carry across that minus 6 now. Right? To get x on its own. So I'm going to take this minus 6, carry it across, and it's going to become what now? Plus 6. So I'm going to have 4 plus 6, and that's going to be equal to 5x. Everybody knows 4 plus 6 is 10, and you have this 5x. we need x on its own now. So we're going to have to divide both sides by 5. These will cancel, leaving us with just x. And 10 divided by 5 is just 2. Great. But one last thing for us to finish it up. Now that we have the values for x and y, all we need to come now and say is, therefore, x is equal to 2 and y is equal to 5. Now y equals 3, see there? Y equals 3. And that's it. It's a little work, but it can be done. And to figure out if you're correct, just substitute the values of x and y into any other equation and see if it's equal to the result. And you're good.